solutions and particular solutions. And so first of all, a general solution contains C, and that is what we looked at yesterday. Okay, all of our answers pretty much had C. A particular solution is when we know a value of y equals f of x for one value of x, also known as the initial condition. And we're going to look at how, if you know the initial condition, you can solve and find a particular solution in any given equation. So let's go ahead and look at what it says. It says find the general solution of f prime of x equals 1 over x squared, where x is greater than 0, and then find the particular solution that satisfies the initial condition f of 1 equals 0. So first of all, we're going to focus on this statement right here, general solution of this. Now the reason why they have to specify that x is greater than or equal to 0, okay, right. So anyway, here we go. To find the general solution, I'm just going to integrate 1 over x squared dx. Because what that's going to do is undo the derivative and give me what f of x equals. And so in fact, what we probably should do is we probably should put f of x equals. Because what we're finding is the general solution at the end. And so now what I need to do is I need to go ahead and integrate that. And so from yesterday we learned that that's basically the integral of x to the negative second power. So the general power rule here, how would I integrate x to the negative second? Yep. So it'll be x to the negative first divided by negative 1 plus c. Now remember, you can't have that, and so what we're going to go ahead and do is simplify that. And what will that simplify to be? Negative 1 over x plus c. That is your general solution right there. So pretty much everything we did yesterday. Now we're going to find the particular solution. And to find the particular solution, notice this. This is an x value right here. And so I'm going to start with my f of x function. F of x equals negative 1 over x plus c. And basically, for your particular solution, you're getting rid of c and you're plugging in some numerical value. And so I'm going to utilize this bit of information. So what this states is that I'm going to replace f of x with 0, and I'm going to replace x with 1. And now I need to solve that for c. And so negative 1 divided by 1, I know, is negative 1. So what does c have to equal? 1. So now my equation, my particular solution, will be f of x equals negative 1 over x plus 1. And there you go. So that is the difference between a general solution and a particular solution, and how you find those. Okay? Now, what we're going to do is we're now going to look at some problems that deal with position, velocity, and acceleration. And so if you know here, notice here, it says a ball is thrown upward with an initial velocity of 64 feet per second from an initial height of 80 feet. Find the position function and find the time at which the ball hits the ground. Okay, so first of all, let's talk a little bit about position, velocity, and acceleration. Okay, position is symbolized with S. That is your position function right here, and I think you have that somewhere. Okay, there's your position. Your velocity, remember, is the first derivative of the position function. And then you have your acceleration function. Your acceleration is the first derivative of the velocity or the second derivative of the position function. And that is how all three of those are related. So your position function is like where an object is located. Your velocity refers to the speed of an object, and then your acceleration refers to how fast an object is accelerating. And so now, I'm given an initial velocity and an initial height. Okay? So first of all, let's go ahead and write down my initial velocity. Okay, I know that v of 0, because that's my velocity at time 0, my velocity at time 0 is 64, correct? I also know that that has to equal my first derivative at 0 because of how the position and velocity are related. Okay? I also know that s of 0 is 80. So those are like that particular solution problem. I've got some particular solutions there. And so what I'm going to do now is I'm going to go ahead and start with my second derivative. And I know that the acceleration due to gravity, does anybody remember that? Feet per second squared. I need that one. That one was meters. There you go, negative 32. Okay? It's negative 32 feet per second. That's your, because it's dropping. Okay? That's the acceleration due to gravity. And so what we're going to do is we now have to work our way backwards. I'm at my second derivative, right? I need to work my way back to the first derivative. Once I get that first derivative, I'll work my way back to the position function. Okay? So I'm going to start by integrating. So I'm going to integrate negative 32, and I'm going to use dt because this is referring to time. So if you integrate negative 32, really what that's going to leave you with is that's going to leave you with s prime. And so in this case, s prime of t will equal negative, what? 32t plus c. So far, so good?
Awesome.
So now let's go ahead and utilize, that's velocity, exactly right. Let's go ahead and utilize this bit of information right here now. Okay, so in place of t, what am I going to plug in? 0. Oops, not that pen. I want a pen. So in place of t, I'm going to plug 0. And in place of, oops, I didn't mean to write that. In place of the s prime of t, I'm going to put 64. So I've got negative 32 times 0 plus c. So what does c equal? 64. So my equation for my velocity is going to be negative 32t plus 64. So I've worked my way back once I found the velocity, but what function do I need to find? The position. So I've got to go back one more time. So what I've now got to do is integrate that. So this is my velocity right here. I've got to go back to my position. So I know that my position function, s of t, will equal the integral of negative 32t plus 64. So what will negative 32t integrate to be? Negative 16t squared. Plus, what's 64 integrate? 64t, and I got my plus c. So that's what my position function is now. The only thing I need to find is what? I got to find c. Okay. So to find c, I'm going to utilize this bit of information. Okay. Just one of those kind of have to. You probably can do a lot of the same thing in every problem. Okay. So I'm going to plug 80 in here, and then I'm going to plug in what for t? 0. So I'm going to plug 0 in here, 0 in here, and what do you get c to equal? 80. So your position function, s of t equals negative 16t squared plus 64t plus 80. So that's your first answer. Okay, that's the position function. Now it says find the time at which the ball hits the ground. Now when I say position, what essentially that means is where a ball is located. Is it located at 1 feet, 2 feet, 3 feet, 4 feet, 5 feet? Okay, so if a ball, or another word for the position would be the height. So if a ball hits the ground, what's the height going to be? 0, right? So what we need to do is we need to find where does this position function equal 0. So all you're going to do is set it equal to 0, and it's just basically a quadratic. So I'm going to set this equal to 0. So let's go ahead and, if we're setting this function equal to 0, hopefully we'll be able to fit this in. What do you know about all three of those numbers? They're all divisible by 16. So let's take the negative 16 out. So if I take that negative 16 out, I'm left with t squared. How many times does 16 go into 64? So negative 4t, and then negative 5. So now I can factor t squared minus 4t minus 5 pretty easy. What will that factor to be? T what? And t plus 1. So what are my two values of t going to be? 5 and negative 1. And you're probably wondering, well, how can it be a negative? Okay. So t equals 5. T equals negative 1. Well, what it means is, if it's a negative, that basically means it didn't start at the ground. Okay. The object might have started at a height, and so see if it would have, went back in time, it would have hit the ground there. And so, when will the object hit the ground? 5 seconds. Because that's what t equals 5 is. But what I said about the negative 1, you can't go back in time.
So one number is always going to be negative?
Not always.
What do you do if it's...
Then you could have two answers. Okay. Because technically, what you could do is have, if an object started at the ground, okay, and then it's propelled up like a projectile, it could hit the ground like 5 seconds later. So when it could start at 0 and 5 both. Okay. All right, so you were given the assignment yesterday. You have today to work, finish, and get the stuff done. Okay.